In this one, we will see four different topics, that is random numbers, sampling, rounding the numbers, and formatting the numbers that get displayed on the screen. But why learn about random numbers and sampling in the first place? The reason is these are very foundational and supporting topics when you are working on creating machine learning models. If you want to introduce some sort of randomness in your data, or you want to select a random subset of your data, these are some of the techniques that you will use on a day-to-day basis as well. Let's begin with creating random numbers. First, I'm going to create the visitors data. That is the number of visitors coming to the portal for 28 days. And I'm going to use random numbers to generate that data. In R, the function to create random numbers is RUnif. UNIF stands for uniform distribution. And the only mandatory argument for this particular function is the number of random numbers you want to create. I have set it as 28, and by running this, we have a set of 28 random numbers, all of it varying between 0 and 1, because 0 and 1 are the default min and max parameters of RUnif. So if you set a different value of this parameters, now I have set it to 1000 to 1100. On running this, my visitors 28 is going to lie between these two ranges. But since these are random numbers, if I run the same function one more time, I will get a different output. Let's check that. So the output from this run and this run are very different, even though both these set of numbers have a minimum of 1000 and maximum of 1100. Now I want these numbers to be still random, but every time I run this function, I want to get the same set of random numbers. This is what is something called as pseudo randomness. The numbers do look random, but it has a repeatability behind it. Because of that reason, we call it as pseudo random numbers to be more precise. Now, to generate the same set of random numbers, what you can do is set the seed right before running the RUnif function. Let me clear the screen. Now I'm going to set the seed to any number. It doesn't matter. You can set it to 100, 1000 or any number that you want, as long as you set it to the same number just before running the RUnif. Let us run this. Now we have this pattern. I'm going to run the same 3 lines of code. Just before running RUnif, I'm running set seed. Now these two output will exactly match. That is exactly the purpose of having a set seed right before generating random numbers. This is a commonly followed practice that you need to follow. Now, it may happen that you want to create data to simulate real world data. For example, if I want to create data to represent the height of white Caucasian males who are on an average having a height of 6 feet. If I'm going to just generate random numbers, it may not be exactly replicant of the real world scenario, because the distribution of data for this white Caucasian male in real world tend to have a normal distribution. Not just this data, but most data that occur naturally tend to follow a normal distribution. And a normal distribution is characterized by two parameters, that is the mean and the standard deviation. Let me clear the screen. So instead of using RUnif, if you are going to generate real world data that follows normal distribution, and real world data typically follow a normal distribution, you want to use the RNorm function and set the mean and the standard deviation. In RUnif, we set the min and the max, but in this one it is different. By doing it, you will get data that looks random, but it's not really random. It is having a mean of 6 and a standard deviation of 0.3. If you look at these numbers, most of them vary around the mean of 6. Now let's do sampling. when is sampling used? Before we go to the code, if you think about it, in real world you will get data. You will not typically be creating data very often. When you get your data, and from that data you want to randomly pick a certain number of rows or certain number of items from that data, whichever format the data is in. To enable that, what we do is basically you create a vector of row numbers or item numbers, and from that vector you will randomly sample a smaller subset. That is what we are doing here with the sample function. Now let's imagine 1 to 100 is the row numbers in your data, and from that you are going to pick 10 rows randomly. You can use the sample function for that. We have randomly sampled 10 rows. If you do the same procedure one more time, you will get 10 more random rows, but you will get different rows. To enable reproducibility, we will use the same technique we did in random sampling or creating random numbers, that is setting the seed. Now I have these 3 lines of code replicated, but I have stored the output in SAMP1 and SAMP2. On running this, the output of SAMP1 and output of SAMP2 should exactly match. Why? Because I am setting the seed right before, just one line before running the sample function. Now, one thing to notice here is when this sampling happened by default, the items that are picked in the previous iteration does not get replaced back into the sample before picking the next one. That is, it is a sampling without replacement. Now, if you want to pick a large number of items from a smaller set, for example, from numbers 1 to 10, you want to pick 20 numbers. You can do so only after replacing the item that you picked earlier. So, in order to do that, you need to set replace equal to true in your sample function. Without doing that and running it, it is going to raise an error saying that cannot take a sample larger than the population when replace equal to false. So turn it to true and run. You will definitely have some repetitions here because there are only 10 numbers, and from that you are drawing 20 numbers out of it. Now let's do rounding, clearing the screen. Now visitors 28 we have generated, but there are decimal points here. I don't want decimal points because the number of visitors coming to a portal can never be in decimals. So on rounding this, any decimal that is greater than 0.5 will be rounded up to the next higher integer. Less than 0.5 will be rounded down. Doing a floor of this will force all these numbers to get rounded down, while doing a ceiling will force it to be rounded up. There's a function called trunc. Trunc stands for truncate. It will truncate these numbers to the next closest integer towards 0. So essentially, in most cases, it will imitate the value of floor if the numbers are positive. Let's run all of these. This is rounding down, ceiling is rounding up. Trunc will just cut off the decimal point. So any number you have, if you remove these decimal points, that's what you will get as a result of trunc. Let's update visitors data. I'm going to call it as visitors updated after doing a ceiling on it.